The Hsuehshan Tunnel, or Snow Mountain Tunnel, is the longest tunnel in Taiwan. The main road connects the city of Taipei to the northeastern county of Yilan. Travel time can take from 30 minutes up to 2 hours. The challenge is to decrease travel time during busy periods. We used data provided by the Taiwanese government. We analyzed this data in order to offer an engineering and a software-based solution. The Hsuehshan Tunnel primarily has 2, sometimes 3 lanes traveling in both directions and 3 to 4 in-out links in both directions. The provided data covers 30.2 kilometers. The throughput of the tunnel is about 3,600 cars per hour in both directions. Based on the data we have created 2 charts. The first, average speed, and the second, intensity of traffic flow, both factored by days of the week. The 2 charts show that the highway has the same intensity in both directions, but the travel time and the congested time to Taipei lasts much longer. Based on those charts, we can define critical points for traffic flow. We designed an app which visualizes traffic flows in order to better understand the reason for a decreasing of average speeds. The app provides data represented visually which anyone can use to make a more informed decision about their commute. It is an iOS prototype currently for the iPhone. It is about 1 megabyte and it visualizes historical data from April to June and shows the average speed for the current day of the week and current average speed of the entire simulation. In order to use the application, after installation, press the search button on the bottom and type Taipei. Choose the result Taipei. It will move the map view to the Taipei city and show the traffic dynamic. Meanwhile, in the background of the app, historical data will download for the simulation. With 3 buttons next to the search button on the bottom, you can restart, decrease, or increase the speed of the simulation, respectively. The app highlights the main problem, a decrease in speed on the way to Taipei. A big contributing factor are the first 10 to 15 kilometers in the beginning of the highway when the cars are in the tunnel. During this point, speed can fall down to up to 5 to 10 kilometers at times. Solutions to this problem are not as easy as they may seem because the highway is completely busy in both directions. Simply reversing the lanes wouldn't work, and using secondary roads isn't an option because they take much too long to reach Taipei. We suppose that the engineering solutions below could improve the traffic situation. These changes will prevent phantom traffic jams. During congested times from Taipei, the speed in the tunnel should be changed manually to 60 kilometers per hour. During very congested times from Taipei, the speed should be changed to 60 kilometers per hour throughout the whole highway. During very congested times to Taipei, the speed should be changed to 40 to 50 kilometers per hour in the tunnel. There should be signs to keep distance and no passing. Based on the information from flow detectors, one can build an automatic system for changing the speed limit at different parts of the highway and especially the tunnel. Unfortunately, there is no solution for this problem based on redistributing car flows throughout the day because the highway is overloaded with cars for many hours in a row. In this case, limitation by even and odd numbers of license plates for very congested times every week can improve speed flows and push people to use public transportation more. This rule applies only for private and small cars. Using this application, people could also see what the current situation is and how it has been historically, possibly suggesting a better time to commute. What's next? One or more of the following solutions, engineering or software, could be implemented. The app could be augmented by real-time data and gamification. In gamification, people can receive points by solving problems altogether and improving traffic situations. For example, involving more people in the app and following recommendations gives you points, which in turn improves traffic flow and gives users satisfaction for their involvement.